the molarity of a solution obtained by mixing 750 ml of 0.5 molar HCl with 250 ml of 2 molar HCl will be. Since we have two solutions, these two solutions are mixed. Given molarity of first solution M1, this is equal to 0.5 molar. Molarity volume of this solution V1, this is equal to 750 ml. Molarity of second solution M2, this is equal to 2 molar. And volume of second solution, this is equal to 250 ml. Now these two solutions are mixed together. So the new molarity M is equal to M1 V1 plus M2 V2 divided by V1 plus V2. This is equal to 0.5 into 750 plus 2 into 250 divided by 750 plus 250, and this is equal to 0.875 molar. Answer. The coagulating power of electrolytes having ions Na+, Al3+, and Ba2+ for arsenic sulfide sol increases in the order. Since arsenic sulfide sol is a negatively charged sol, As2S3 sol is a negatively charged sol. So positively charged ions cause coagulation. And according to Hardy-Sulz rule, coagulation power is directly proportional to valency of ion causing coagulation raised to the power of 4. Therefore, highest coagulation power, Al3 plus has highest coagulation power and Na plus has lowest coagulation power. So order is Na plus, Ba2 plus and Al3 plus. So first is the right answer. How many liters of water must be added to 1 liter of an aqueous solution of HCl with a pH of 1 to create an aqueous solution with pH of 2? Since pH is equal to 1, this implies concentration of H plus initial. This is equal to 0.1 molar. And this is, let us say, M1. Now we have to convert this solution of which has pH equal to 2. So concentration of H plus 2, this is equal to 0.01 molar, and this is, let us say, M2. Now V1 is 1 liter. So from dilution law, M1 V1 is equal to M2 V2, or 0.1 into 1 this is equal to 0.01 into V2. This implies V2 is equal to 10 liter. Since we have to calculate liters of water which must be added to 1 liter of an aqueous solution of HCl. Therefore, liters of water added, this is equal to 10 minus 1, this is equal to 9 liter. So third is the right answer. Third is the right answer. Now, experimentally it was found that a metal oxide has formula M0.980. Metal M is present as M2 plus and M3 plus in its oxide. Fraction of the metal which exists as M3 plus would be, since formula is M0.980. Let us assume this formula can be written as M3 plus, and let us assume M3 plus is X. M2 plus, it will be 0.98 minus X, and O2 minus, this is 1, by charge balancing. (3x) plus 2 into 0.98 minus X, this is equal to 2. This is total positive charge and this is total negative charge. Or X, this is equal to 2 minus 1.96 means 0.04. Therefore, percentage of M3 plus, this is equal to 0.04 divided by 0.98 into 100, and this is equal to 4.08%. So first is the right answer. Given E0 Cr3 plus is Cr, this is minus 0.74 volt. E0 MnO4 minus 2 Mn2 plus, this is 1.51 volt. E0 Cr2 or 7, 2 minus 2 Cr3 plus, this is 1.33 volt. And E0 Cl2 Cl minus, this is 1.36 volt. Based on the data given above, the strongest oxidizing agent will be. So, higher the value of, these values are standard reduction potential data. So, higher the value of a standard reduction potential data, greater is its tendency to get reduced. Hence, substance will be a better oxidizing agent. Since E naught MnO4 minus to Mn2 plus. This is equal to 1.51 volt, which is highest. Therefore, MnO4 minus is the strongest oxidizing agent. So third is the right answer. The rate of a reaction doubles when its temperature changes from 300 Kelvin to 310 Kelvin. Activation energy of such a reaction will be R is 8.314 joule per Kelvin per mole and log 2 is 0.301. Since we have a formula log K2 by K1, this is equal to EA upon 2.303 R into 1 by T1 minus 1 by T2. Since rate of reaction becomes double, so log 2 or log 2, this is equal to EA upon 2.303 into value of R is 8.314. Take it in kilojoule. So into 1000 into 1 by 300 minus 1 by 310. Solving, we get EA is equal to 53.6 kilojoule per mole. So fourth is the right answer. A piston filled with 0.04 mole of an ideal gas expands reversibly from 50 ml to 375 ml at a constant temperature of 37 degrees Celsius. As it does so, it absorbs 208 joule of heat. The value of Q and W for the process will be R is 8.314 joule per Kelvin per mole and Ln 7.5 is equal to 2.01. Since temperature is equal to constant, T barabar constant, this implies delta T is equal to 0. For ideal gas, delta U is equal to N CVM delta T, and this is equal to 0. Or the change in internal energy delta U is equal to 0. Since it absorbs 208 joule of heat, since heat is absorbed, therefore, whenever heat absorbs, we take positive sign, therefore Q is equal to plus 208 joule. Now, from first law, delta U is equal to Q plus W. Delta U is 0. This implies W is equal to minus of Q, or W is equal to minus of 208 joule. So Q is 208 joule and W is minus 208 joule. So fourth is the right answer. A gaseous hydrocarbon gives upon combustion 0.72 gram of water and 3.08 gram of CO2. The empirical formula of the hydrocarbon is, let us assume hydrocarbon is CXH. On combustion with oxygen, it gives X moles of CO2 and Y by 2 moles of H2O. Since CO2 is 3.08 gram, this implies 3.08 divided by 44. This is equal to 0.07 mole. And water is 0.72 gram. This implies 0.72 upon 18. This is equal to 0.04 mole. Whenever moles of CO2 is 0.07, moles of water is 0.04. It means whenever moles of CO2 will be 7, moles of water will be 4. This implies moles of CO2, suppose 7, so X will be equal to 7 and Y will be equal to 8. Y by 2 is 4. Y by 2 is 4. Y by 2 is equal to 4. This implies Y is equal to 8. Therefore, C7H8 is the right answer. See, most question is, for gaseous state, if most probable speed is denoted by C star, average speed by C bar, and mean square speed by C, then for a large number of molecules, the ratios of these speeds are, since C most probable speed, this is equal to root under 2RT by M, and this is equal to, it is given C star. C average, this is equal to root under 8RT divided by pi M, and this is equal to C bar. And C RMS, this is equal to root under 3RT by M, and this is given as C. Therefore, C star is to C bar is to C, this is equal to root 2 is to root 8 by pi is to root 3. This is equal to 1 is to root 4 by pi is to root 3 by 2. This is equal to 1 is to 1.128 is to 1.225. Hence, second is the right answer. Consider the following reaction: XMnO4 minus plus YC2O4 2 minus plus ZH plus gives XMn2 plus 2 by CO2 plus ZY2H2O. The value of X, Y and Z in the reaction are respectively. Since MnO4 minus is reduced to Mn2 plus. Balance oxygen by adding 4 H2O. Now balance hydrogen by adding 8 H plus. Now balance charge by adding 5 electron. This is reduction. Now oxidation of C2O4 2 minus. So C2O4 2 minus, this gives CO2, 2 CO2. Carbon is balanced, oxygen is also balanced. So balance charge by adding 2 electron. Now multiply, this is 1, this is 2. Multiply this by 2 and this by 5. We get 2 MnO4 minus plus 5 C2O4 2 minus plus 16 H plus. This gives 2 Mn2 plus 10 CO2. Therefore, X is equal to 2, Y is equal to 5, and Z is equal to 16. Hence, 2 is the right answer. Energy of an electron is given by E is equal to minus 2.178 into 10 to the power minus 18 joule into Z square upon N square. Wavelength of light required to excite an electron in an hydrogen atom from level n barabar 1 to n is equal to 2 will be given H is equal to 6.62 into 10 to the power minus 34 joule second and C is equal to 3 into 10 to the power 8 meter per second. All data are standard data. We know all data are standard data. So we can solve in a simpler way. Since let us assume this is n is equal to 1. So energy of this level, this is equal to minus 13.6 electron volt. And this is equal to, for hydrogen atom, it is n is equal to 2. And energy of this level, this is equal to minus 3.4 electron volt. Energy difference between these two, this is 10.2 electron volt. Now we have a formula. Energy in electron volt, this is equal to 12,400 divided by wavelength in angstrom. This implies lambda in angstrom, this is equal to 12,400 divided by energy is 10.2. And this is almost equal to 1214 angstrom. Therefore, lambda is equal to 1.214 into 10 to the power minus 7 meter. Hence, fourth is the right answer.